Hi everyone, I welcome you all in the quick solutions discussion of All India AIATS Test Series Medical 2019. And I'm here with the test number 15, code A and B. And yes, we are just going to discuss the section chemistry. Let's begin it with the very first question, that's question number 61. Amount of the work done by 2 mole of an ideal monoatomic gas when its temperature is increased by 2 Kelvin at constant pressure. So simple question in which we need to just find out the work done.
Here as W is equal to P delta V and PV is nRT. Therefore, P delta V is equals to nR delta T.
And work done by an ideal monoatomic gas is dependent on the number of mole and the change in temperature. That formula that I'm just going to use here is nR delta T. So, number of moles are already given in the question. That's 2 mole, R value, and multiply the change in temperature. What's the change in temperature here? It's increased by 2 Kelvin. So, what is the change in temperature? Definitely, it is 2 Kelvin. And now on that basis, this work done becomes 4R. Now, if this is the work done, then definitely you can easily choose option 3 as the correct answer for this question. After this, the next question is here, question number 62. If pKa of monobasic weak acid HA, here is pKa value mentioned, that is 5 in the question it's given, and this is monobasic weak acid HA. The pH of 0.01 molar NaA solution is. It means in this question you need to just find out the pH of the salt which is prepared by the reaction of monobasic weak acid and a strong base NaOH. So the formula for the pH value is equal to 7 plus, because it is basic solution, so pH is slightly more than 7. So 7 plus half of the pKa value plus log C. What is C here? C is the concentration. So it is 7 plus half. And what's pKa here? That's given in the question. 5 plus log C. What is log C? It is 0.01 molar. And that I can also write here 10 raised to the power minus 2. Now, the simplified form for this becomes half of 5 minus 2, because it becomes minus 2 log 10 and log 10 is 1. That's why minus 2 I'm directly taking here, and it becomes 7 plus 5 minus 2, 3 by 2. And this is equal to 8.5 that you'll obtain after solving. Where this is given? It's given here in option 2. Just choose option 2 as your correct answer. After this, here's question number 63. If the density of a gas at 27 degrees Celsius is D, then at which temperature does the density of the gas is decreased by 25% at the same temperature? It means you need to just check what would be the density change. Density of the gas at 27 degrees Celsius is given, that's D. Temperature is mentioned, and here what you are just going to do, you are just going to decrease the density by 25% at same pressure. Then you need to just find out the temperature. What's the relation between density and temperature? We know that as per ideal gas equation, P is equals to dRT by M. Here pressure is constant, R is constant, and the same gas is here. That's why M is also constant. So what are the factors which are variable in this case? In this case, density is variable. So we can simply say that density is inversely proportional to temperature on this basis, you can say. And on that basis, we can simply say that T1 is equals to D2 because dt is a constant. Now just place the values here. Density, that was initially D. Temperature, 27 degrees Celsius. It means 300 Kelvin. That's equal to D2. What is D2 here? So initial density minus 25% of D is decreased. So D into 25 by 100. This would be the density. And what is the temperature here? That you need to just find out. In this case, this value would becomes D minus 0.25D, or simply you can say it is 0.75D into T2, and this is D into 300. D can be cancelled in this way. So what would be the value of T2? That T2 value can simply be written as 300 upon 0.75, and that value is equal to 400, and this is in Kelvin. So if this temperature is 400 Kelvin, that what would be the value in degree Celsius? What you need to do, just subtract 273 from this. So after subtracting, you will get that this value is 127 degrees Celsius. So this is your final answer. On that basis, I can choose option 4 as my correct answer. Now, after this, next question, question number 64. Which pollutant is main cause of ozone depletion? We should always know that whenever we talk about ozone layer formation, UV rays are important for the formation of ozone layer, while if I talk about the depletion of ozone layer, CFCs are responsible for that. CFCs are chlorofluorocarbon, you might be knowing. And on that basis, option 3, I'll choose here chlorofluorocarbon. That's given in option 3. Question number 65. Maximum ionization enthalpy among the given elements is of. What are the elements given here? Boron, carbon, nitrogen and oxygen. Let me write here their electronic configuration to find out the maximum ionization enthalpy. What is ionization enthalpy? That's the amount of energy required to remove an electron from the valence shell of an isolated gaseous atom. So, if I talk about boron, atomic number is 4, that's 1s2, 2s2. For the carbon it is 1s2, 2s2, 2p2. For nitrogen it becomes 1s2, 2s2, 2p3. And for oxygen it is 1s2, 2s2 and 2p4. Now first of all, I'll compare these three elements, boron, carbon and nitrogen. These three are the elements of the same period. Even all four elements are the elements of the same period. Now, if I talk about boron, carbon and nitrogen, nitrogen has maximum effective nuclear charge because size is reducing and number of
proton in the nucleus
are increasing one by one. That's why nitrogen has maximum effective nuclear charge, and that results in its high ionization enthalpy. So among these three, nitrogen has maximum ionization enthalpy. What about nitrogen and oxygen? Oxygen has more effective nuclear charge, but in case of nitrogen there are 3 electrons in p orbital. Here you can clearly see it is showing the half-filled configuration, and half-filled configuration is also stable and removal of electron from it becomes difficult. So it has high ionization enthalpy as compared to oxygen, because in this case half-filled configuration is not there this way. So which is most stable? Which has maximum ionization enthalpy? Definitely nitrogen. And on that basis I'll choose option 3 as my correct answer. After this, here's another question.